everyone, welcome back to my channel Science Sutra. In this video, we will be discussing with other concepts of motion, that is graphical representation of motion. How we can represent motion graphically, that we need to understand in this video. Okay, in the next page you will see basic terms. Before going to the graphical representation of motion, these three definitions you have to know. What are they means? Graph. How you can define a graph? A graph, if you see the graph, what thought will comes to your mind? See, graph is nothing but a diagram that represents the variation of a variable in comparison with that of one or more other variables. See, the best example what I can give here, if I take two variables like x, y, okay, I can plot that two variables graphically, right? I will take x in this x-axis and y along y-axis. So, if I take y is changing, then you can see the change in x also, right? So, it is nothing but, that graph is nothing but a diagram that represents the variation of one variable. Variation means the change of one variable compared to the other variable. So that whatever the graph that we are seeing, whatever the graph that we are getting after seeing the variation of one variable with respect to the other variable, that diagram is called to be a graph. Okay. And next, linear graphs. In the graph itself, you will see number of varieties. Okay, in this video, we will be seeing mainly the linear graphs as well as the non-linear graphs. Then what are linear graphs? Linear graphs are nothing but the straight line graphs. What do you mean by that? See, if I take two variables like x and y, okay, I will plot x here and I will plot y here. If I get a straight line passing through the origin like this. This O is called to be the origin, right? So whatever the line that we got that is passing through the origin, and this kind of graphs are called to be the linear graphs. Then what will be the non-linear graphs? Means the non-linear graphs are nothing but the graphs which doesn't have a straight line. Instead of straight line, you can see different curve patterns you can see like this or like this. Okay, these kind of graphs are called to be the non-linear graphs. I hope you have understood. Let's move on to the next. That is distance, or the two variables that we need to take. What are the two variables that we need to take here? We need to take distance and time. Okay, and distance time graph. What do you mean by distance time graph then? Distance time graph is a graph that shows the change in position of object with respect to time. Change in position is nothing but change in distance. I have to take distance along the y-axis as well as the time along x-axis. Okay, if I plot, okay, whatever the diagram that we will get after plotting the points, okay, that is related to the distance and time, that kind of graph is called to be the distance time graph. Then what all quantities you can find from distance time graph? You can find speed, right? What is speed? How we can define speed as? Speed is nothing but the distance traveled by the object to the time taken, right? See, if I plot the graph of distance time graph, we will get, and one more is non-uniform speed. Okay, graph is called to be a graph which shows the change in position of the object with respect to time. This is the definition for distance time graph. You can write here this definition. Okay, next, in distance time graph, what are the two variables that we are taking? One is distance and one more is time. And one more thing you have to know, Here the distance is called to be a dependent variable. Dependent means it will vary according to the change in time. Okay, it is depending on the time variable. So this distance is called to be the dependent variable. Okay, and one more variable which I have taken is time, right? So time is called to be the independent variable which we have taken along x-axis. Okay, these 2 points we need to know if we want to know about distance time graph. Next, distance time graph. As I told before, distance time graph is mainly used to find or is mainly used for plotting the speed, right? What kind of speeds you can plot? Uniform speed, non-uniform speed, as well as when the object is said to be at rest. When the object is not changing its position with respect to time, then you call that object is said to be at rest. And for that object also we can write the distance time graph. Okay, then what is uniform speed? How you can define uniform speed? See, when an object travels equal distances in equal intervals of time, then we call that object is said to be in uniform speed. Then how we can get or how we can plot the graph for uniform speed? See, for example, here I have given the distance, okay, and along the x-axis I have taken time, right? I will mention the unit of distance as kilometer, and here in terms of hour I will take. I will say whatever the graph I wrote, it is for uniform speed. Why? If I see here at 1 hour, if I plot, if I take this point 1 hour, what will be the speed here? It is covering, okay, I will write here 2 columns. One is for distance and one is for time. Okay, distance I will take in terms of kilometer and time in terms of hour. So for 1 hour, it is covering 50 kilometers of distance. Okay, next for 2 hours, how much it is covering? It is covering 100 kilometers. Okay, for 3 hours, it is covering how much? 150 kilometers. For 4 hours, how much it is covering? It is covering 200 kilometers for 4 hours. Correct? I will call this object is moving in with uniform speed. Why? Because see, if I take the difference of these two, what will be the difference? It will be 50. If I take the difference of these two, I will get 50. Here 50, right? And here 1, 1, 1. That means for equal intervals of time, it is covering equal distances. So that object is said to be at uniform speed. And what will be the graph? It will be a linear graph. Why? Because I am getting a straight line passing through the origin. Okay, this is for uniform speed. Next, for non-uniform speed, how we will get the graph we need to know. See, for the non-uniform speed, if the object covers, see, for non-uniform speed, if the object covers unequal distances in equal intervals of time, I will call that object is said to be at non-uniform speed. Okay, and the graph for that non-uniform speed, it will be like this. It will be a curve which is passing through the origin. See, from the graph itself you will get to know the distance value as well as the time value, right? Okay, I will take distance in terms of meter and time in terms of seconds. Okay, see, if I take this point 2 seconds, what will be the distance it has covered? Means it has covered nearly, okay, maybe 2. It has covered nearly 2 meters. Okay, for 4 seconds, it has covered 5 meters. And next for 6, it has covered nearly 9. 4 seconds, sorry, for 6 seconds it has covered nearly 9. And for 8 seconds it has covered nearly 15. Okay, what I need to take here, 8, 15. Okay, here I will say the object is said to be at non-uniform speed. Why? Because I need to take the difference. What will be the difference? 5 minus 2 is 3, 9 minus 5 is 4, and 15 minus 9 is 6. Correct? So here if I take the difference, 4 minus 2 is 2, 6 minus 4 is 2, and 8 minus 6 is also 2. See here, whatever the distance that is covered by this object is different at equal intervals of time, then that kind of object is called to be, is said to be moving at non-uniform speed. And what will be the graph for that kind of object when it is moving with non-uniform speed? The graph will be looking like this, a curve that is passing through the origin. Okay, next, if the object is said to be at rest, rest means if it doesn't change its position with respect to time, then that kind of object is said to be at rest. Then what will be the graph for that? Take 0, 1. Okay, in terms of meters and time in terms of seconds. Okay, at 0 seconds it has traveled 1 meter. Okay, then what happens after 1 second? It is in 1 meter, and after 2 seconds it is again into 1 meter, like this. See, even though the time is elapsing, whatever the distance covered by that object remains same, right? What this line represents, it is representing the distance value to be same, even though you are changing the time value. Even though the time is changing, the distance remains the same. Then this is the graph that we are getting for the object when it is at rest. I hope you have understood this concept. Okay, let's move on to the next. Next, what means we need to derive, okay, we need to derive how we can derive the velocity, how we can derive the speed by taking distance time graph. Okay, I'm writing here time along x-axis I will take in terms of seconds, and distance I will take in terms of meters. Okay, I will take a linear graph like this. Okay, and I will mark here as 1 meter, 2 meter, 3 meter, 4, 5, 6, and here it is 1, 2, 3, 4, 5, 6, so on. Okay, and here I will take this as O, and I will consider 2 more points here, that is A and one more is B, and I will take here and I will draw 2 parallel lines to the distance. Okay, I will take this as T1, T2, and I will plot similar parallel lines to the time axis, and I will take that as S1, S2. Okay, sorry, yes, S1, S2. S represents the distance. Okay, so we all know that, and speed, sorry, here I need to take speed. Speed is represented by the symbol V, and how we will define speed as, speed is nothing but distance traveled by the object to the time taken. Correct? See, if I consider the 2 points A and B, okay, and if I consider the slope of this, how I will get the slope? Slope is equal to, I will consider one more point here. Slope is equal to CB by AB, right? Here slope is nothing but I need to consider the speed, that is V. And what is CB here? That is S2 minus S1 divided by T2 minus T1. Why I am taking S2 minus S1 means, see, if the object is moving from O and it has reached the A point, okay, see, from O to A it has traveled a distance of S1 and again it has moved further by covering a distance of S2. Then what will be the total distance means I need to subtract S2 minus S1 divided by, in the same way it has taken time T1 to cover a distance up to A, and again further it has moved to C by covering time T2. Then the total time taken will be T2 minus T1, and here S2 minus S1 I need to consider. So the slope is nothing but the velocity or speed. Why I am saying speed or velocity? See, if I take whatever the distance covered by the object is equal to displacement. I need to write here. This point is important. If distance is equal to displacement, then I can say, what I can say? Then the slope or the speed is equal to velocity. That is, velocity is nothing but displacement by time taken. Okay, if I consider this condition, then only I will say the velocity is nothing but displacement by time taken. So velocity is also equal to S2 minus S1 by T2 minus T1. Why? Because displacement is equal to distance as well as time will remain the same. So S2 minus S1 by T2 minus T1 is also the expression for the velocity from distance time graph. Okay, this is the point which you need to know how you can find the speed value, or else you can find the velocity from the distance time graph. Next, let's move on to the velocity time graph. See, what is velocity time graph? What the name itself indicates, this graph is mainly containing what kind of variables? Velocity as well as time, where velocity will be the dependent variable and time will be the independent variable as usual, which I have seen in distance time graph. And here time is represented along x-axis as well as the velocity is represented along the y-axis. And from velocity time graph, what all you can find? As we know the acceleration term, right? Acceleration is equal to, how we can define the acceleration? It is nothing but the change in velocity to the time taken, right? From velocity time graph, we can find the acceleration. Okay. See, we will discuss now one by one different cases. What are that cases means? See, velocity time graph for uniform motion. How the velocity time graph will look like for uniform motion. See, as we know, the uniform motion is nothing but the object covering equal distances in equal intervals of time. And if I take the time taken, why I am taking displacement means, see if the object covers 1 meter in 1 second and 2 meters in 2 seconds and 3 meters in 3 seconds. See, if I take these differences, what you will get? It is covering equal distances in equal intervals of time. So, how you will calculate velocity? As velocity is nothing but displacement to time taken. If I take first case, 1 meter to 1 second, 1 by 1, that is equal to 1. And in the second case, what will be the velocity? It is 2 by 2, that is also equal to 1, right? So, in the third case, what will be the case? That is 3 by 3, that is equal to 1. That means whatever the velocity that we are getting, it will remain constant for the uniform motion, right? See, the example which I gave is a uniform motion, right? Here it is covering equal distances in equal intervals of time. In that case, whatever the velocity that we are getting, it will be remain constant. So I have written a parallel line to the x-axis. Here, even though the time elapses, the velocity remain constant. Okay, if I am talking with respect to velocity and time axis, I need to say like this. See, even though the time elapses, the velocity value remain constant, and that is the case for the uniform motion. See, if the velocity is changing, if the velocity value is changing, that means I need to consider uniform accelerated motion. Why I am saying uniform accelerated motion means whatever the velocity that is changing, it is, see, whatever the velocity that is changing, that remains constant, constantly increasing. See, if I will give one example for this, okay, that is velocity and time. Okay, see, the object covers, I will take minutes, okay, in terms of minutes. In 2 minutes, it is covering a distance, or it is having a velocity of 4. What is 4 meter per second? Or I will take this in terms of seconds only. Okay, so it will be 4 meter per second, and after time of 4 seconds, you will see an increase of 8 meter per second. Then, if I take a value of 6 seconds, and you will see an increase of 12 meter per second. That means it is constantly increasing. See, at 0, it will be both will be 0. After here, I will take the scale as 2, 4, okay, and 6. Here, when it elapsed of, when you will see a time of 2 seconds, you will get a velocity of 4, okay, and when it is at a time of 4 seconds, you will see a velocity of 8. That means it is constantly increasing in this order. So we are getting a linear graph for uniform accelerated motion. This is very important. Okay, for uniform accelerated motion, we will get a linear graph when we are talking about the velocity time graph. And in that case, in the case which I discussed previously, that is for distance time graph, when you will get a linear graph, when the object is at given here, it is for retarded motion. Retarded means the velocity is decreasing with time. So how it look like for the retarded motion means the velocity graph is in this direction. That means as the time elapsing, the velocity value will be decreasing. Okay. I will give one more example for that. What is that means? Velocity I will take, okay, and I will take time. See here, for 2 seconds, it is, sorry, for 4 seconds, it is decreased to 3, and for 6 seconds, it is decreased to 2, like this. What, as the time is elapsing, as the value of time is increasing, you will see the decrease in the velocity value. So, for that kind of retarded motion, the graph of velocity time will look like this. Okay, means you can find the value of acceleration. As I told, you can find the value of acceleration also. Okay, how you can find means easily you need to you need to find the slope. Acceleration is nothing but the slope, and it is equal to the velocity or change in velocity. I have to take change in velocity to the time taken. Okay, this is very obvious, which we can directly get. But if we want to get the value of distance or the value of displacement, can we get from this? Can we get? Yes. Why? Because we know how we can define the velocity as displacement to time taken, right? So, how we will get displacement value from this? Displacement is equal to velocity into time, right? This we need to know. How we will get from, how we will get graphically, that we need to understand. Yes. See, if I take a linear graph like this, where I will consider the velocity along y-axis as well as the time along x-axis. I will take velocity in terms of meter per second and time in terms of seconds. Okay, I will plot some points here. Okay, like this, and I will take the scale as 10, 20, 30, 40, 50. Okay, and I will take here 5, 10, 15, 20, 25, like this. And I will consider 2 points here, that is A and one more is B. Okay, one is A and one more is B. I need to draw 2 parallel lines like this. Okay, that gives the value of T1 and T2. Then what I need to do, I need to join this point A to the point B line, and I will mark and I will write with an alphabet, that is D. I will take D and I will draw like this. Okay, so I have splitted this into a triangle and into a rectangle. Okay, I will mark here A, B, D. I will take here as E and here as F. Okay, so if I want to get the value of displacement, I need to take the area under this curve. Okay, area under this points I need to take. So I will take displacement as ES, that is equal to, I need to write area, that is A E F dB. A E F dB. Okay. If you are not seeing this, I will change the color to yellow. Okay, and I will mark this as E F D B A. Okay, so I need to consider the area. What is that area? A E F D B. Then how I can split that area as area of the triangle A B D plus I need to consider the area of the rectangle. What is that rectangle? AEFD. Then what is the area of the triangle? What is the area? That is half into base into height, right? That is the formula for the area of the triangle. And what is the formula for the rectangle? That is length into breadth. Okay, I will write first as length into breadth. Now we need to find what is base. Here I will write base is AD, right? Base is AD, and what is the height? I need to consider height as BD. So height is BD. Next, for the rectangle, what is the length here? I need to consider length as AE. Length is AE, and what is the breadth? That is EF. Breadth is EF. Okay, so I need to substitute the terms here. Okay, so it is equal to of into base means AD into BD plus length into breadth means AE into EF. Okay, this is how we can find the value of the displacement by taking the area under the graph. Okay, and this completes this topic. It is velocity time graph. If you like this video, please like, share and subscribe to my channel Science Sutra. And I will be coming up with few more concepts regarding the motion, okay, in my next videos. Thank you.